Welcome back to Austin.
It's great to be back.
Saw you walking down First Street yesterday, or Congress, heading over to Veracruz like nothing had changed.
Nothing had changed.
I was coming up Congress. You were walking down. You right where you were headed.
I got a walking meeting in, as I was describing to you earlier, around Town Lake today. Felt good to be back. I haven't been gone that long. It's been 2 weeks.
Yeah, feels like like you were on vacation or something.
Yeah, and I have been leaving for the summers.
Yeah, you do spend the summer on the shore, so
yeah, it does feel good to be back though. It is weird staying in a hotel.
We're gonna need to find some way to have it be fairly regular.
I think it's gonna be fairly regular.
How many times per day do you think you're gonna eat Veracruz while you're here?
I'll probably have it tomorrow too. I'm gonna skip today. I'm gonna go get lunch with Ryan Gentry after this, and I think we may do something in the proximity of the park.
Got your steps in?
Got 20,000 steps in already. We did the long route in Town Lake today, which I've never done before.
I feel like missing the lake is probably going to be the biggest adjustment. You have the shore, but...
We have the beach. I've been walking, doing push-ups and air squats on the beach every morning, which has been good, but once you get back to Philly proper, it's hard. We do have some parks around us, but I'm going to try and keep the walking up. Dr. Jack Cruz is really... in my mind, get the sunlight, get the steps.
I was at the park. We were at the park on Sunday, and we saw Katie and Mike, and they were talking about Sunmax, and just kind of happened to see them, and that's inspired me to start. And I've been paying attention to Jack for quite a while now, but it's time to put that into action.
It is the sun provider.
I told Kaylee she was wearing sunglasses. I was like, "Hey, Uncle Jack says bad for your eyes."
I felt good. Yeah, because I didn't know sunglasses were bad until like 2 or 3 years ago. Bad for your eyes. But I naturally just discarded sunglasses like 10 years ago because I would either lose them or they'd never stay on my face. And so I've been sunglass free for a decade.
I have been as
well. Yeah.
All right. Got you back in the studio?
Back in your city. You're in the interview seat. Maybe. What are we doing here?
What are we doing here? Starting a show as part of TFTC on mining and energy. Yeah, not just mining, but an energy-focused podcast, a cross-section of Bitcoin mining, and energy. And a lot of the inspiration of it has been just me increasingly focused on the fact that mining is consistently talked about as a point of centralization. And it's a really interesting subject on the energy side. I think that the energy side of Bitcoin is as much of a rabbit hole as money is a rabbit hole. And, at Zapprite working on Bitcoin payments, it's not, my main goal of doing this is to help for the education around the convergence between Bitcoin and energy. But also a lot of our customers at Zapprite and early adopters of Bitcoin payments are in the mining ecosystem naturally. They have revenue that's Bitcoin denominated, and they have customers willing to pay in Bitcoin. But most importantly, there are these knowledge gaps that exist around Bitcoiners not appreciating energy, Bitcoin miners really being sophisticated in energy and energy economics, but maybe not being as familiar with the technical underpinnings of Bitcoin. And then there are legacy energy professionals and legacy energy industry that have a lot to add to Bitcoin, but don't understand it, as well as regulators and legislators that specifically influence policy or grid operations that would benefit for a Bitcoin podcast that was focused around not just mining, but energy fundamentals and how that converges. And given the fact that the TFTC studio is here and that we're in the center of hash being Texas and everything that's happening around the state, it won't just be about ERCOT and what's going on in Texas, but I thought we could leverage the infrastructure that's already here. We got the best studio in America, maybe the country.
Probably the world, actually.
Yeah, definitely Austin. So and you have a long history of working on mining, from various different cross sections of it. So, looking forward to diving into helping Bitcoiners understand the energy side, helping miners further entrench themselves in the working of the network and their role to play in it. Because I think one of my observations is, while there are different aspects of Bitcoin mining that are centralized and potentially increasingly centralized, it's really to the detriment, ironically, to miners themselves, and that the miners, have a role to play in helping to solve that problem.
Yeah, I agree. The energy rabbit hole, I've fallen down it twice. Once early in my career, when I was working at a managed futures fund, we were trading commodities, energy being part of that bucket of commodities. So I learned a lot about macro influences on energy, but I didn't really fall far down the rabbit hole until Great American Mining. I joined them in 2018. And we went on that journey to mitigate flare gas in the Bakken using Bitcoin mining. And it is hilarious to me that you can spend years on Bitcoin, myself, like understand the economic principles, the distributed protocol, how it works, and even really understand hash rate and the difficulty adjustment. But it wasn't until I joined Great American Mining and really was forced to do a deep dive on Bitcoin mining economics, which forces you to understand energy systems, that I came to have like a full grasp of the industry. And even today, I won't admit to be the end all be all expert on Bitcoin mining and the intersection of mining and energy, but I think I know enough to be dangerous and have learned a lot over the last 7 years to have a pretty good perspective on where the market was in the past, where it is today, and where it may be going in the future.
Yeah, maybe talk a little bit about, so you joined Great American Mining in 2018. You've worn the hat of an operator. You mine yourself, I believe, through 1031 invests in mining companies. You sit on a board of a mining company. But from 2018 to today, 2025, in your view, how has not just like the industry changed, but the sophistication around energy strategies maybe advanced?
I think it's in order of magnitude. It's made an order of magnitude, probably multiple orders of magnitude advancement in terms of the understanding. Because you have all these, I think the 2021 Chinese mining ban like really forced operators in the United States to step up their game and really think about the power aspect very, very hard. And I think we've seen that, the products of that here in ERCOT, and to a lesser extent, but pretty advanced as well, up in the Tennessee Valley Authority and the TVA. And that's the thing with mining and energy. There's so many variable inputs that go into both industries. It's like trying to combine them is, you have to be very smart, but it's also like an art form. You have timing the market on the energy side of things and timing the market on the Bitcoin side of things. I think when it comes to mining, when you go back to when I first got in, you had like the S17s coming out, you had the What's Miner M20Ss. And so on just a hardware side, we've had incredible advancements in the efficiency of the machines in terms of joules per terahash, like how much they can produce much more hash with smaller amounts of energy. And at the same time, you've seen the proliferation of these publicly traded miners like Riot, Marathon, Clean Spark, Iron, and they've really industrialized mining, particularly on grid. But then you have this whole other aspect, which is off-grid mining. And now with projects like the BitAxe, you're getting at-home mining. And so there's many different ways to skin the cat of a mining operation. And I think even before 2018, I think between 2016 and within the last 2 or 3 years, the advancements on the hardware side were so quick. And the way in which you acquired ASICs was not how it's done today, which I think is much more efficient and better for the miner. But you had like pre-sales and pre-orders, and the cost per terahash got out of whack in 2021 particularly. But I think we've settled down into a point in time where the operators are more professional. They're more methodical about their deployment of capital, both on the hardware side and the infrastructure side of locking down the power and building it out. And so as it stands today, I think the mining industry has matured. I do think outside of ERCOT and even within ERCOT to a certain extent, energy producers really have not fully grokked Bitcoin mining and how it can increase their efficiencies and their revenues and make their operations more secure in the long run, economically viable, sustainable, as you like to say. There definitely are some who get it and are early leaders, but I think the mining industry has matured to a point. I do think the energy industry is lagging a bit in terms of understanding the benefits mining can provide them in the long run.
Yeah, and for a frame of reference, and I want to go back a bit, but I believe in 2017, the network had approximately 5 exahashes, and today it's
800.
800.
Between 8 and 900.
Yeah, between 8 and 900. So the network hash rate, and I want, for given that this is the first podcast of this series that we're doing under the TFTC umbrella, I want to do some basics to just ground people, even Bitcoiners, and what certain things represent and are. But that's from just as an order of magnitude, hash rate in the Bitcoin network has increased by 160 times the past 8 years. And that necessarily, as mining becomes more competitive, and there might be various reasons that turning on a home miner and solo mining with a small amount of hash rate doesn't need to be thought of the same way that a miner that is running a sophisticated operation might think about their own economics. But over the past 8 years, it's shifted to, if you are going to have a viable Bitcoin mining operation, and whether it's people that own power generation start to look at Bitcoin mining, that increasingly it seems like just out of the increase in the hash rate of the network, that if you're not optimizing for an energy strategy or realizing that you're in the business of energy development and procuring cheap power and optimizing around that you're not going to have a sustaining operation. Where do you see us in that kind of process to the shift of big efficiency gains coming from the hardware side versus optimization around energy and cost of energy, or uptime, downtime, curtailment, thinking about that?
Mm-hmm. I think we're definitely in a better spot, but have a lot of room to grow there. And I was actually in DC last week at the Bitcoin Policy Institute Summit, and I was talking with Reed Browning and Isaac Fithian, who were at Great American Mining with me. They're still in the industry, and we were having this conversation. Our thesis, even at Great American Mining, was that ultimately, due to the competitiveness of the mining market, as you mentioned, Bitcoin mining is the most competitive, ruthlessly competitive market in the world. Anybody can buy an ASIC, or excuse me, an ASIC's not the right term, can buy a mining machine with a bunch of ASICs on it, plug it in, and boom, they're producing hashes and competing for the production of blocks and the reward that is Bitcoin, the subsidy, plus the transactions associated with the fees associated with the transactions in that block that they may ultimately win. And our thesis back at Great American Mining was that ultimately power companies are like, it's either who's going to become who first. The miners going to become energy companies, or the energy companies going to become miners. They're going to converge and just be one operation at some point. And so at Great American Mining, we were doing off-grid mining. We learned this lesson the hard way. We were doing flare mitigation in the Bakken on the well pad in harsh conditions in the middle of North Dakota. And we learned the hard lessons of sort of gas quality, flow quality, depending on like if the pipe froze because it was negative 40 degrees, like that could prevent you from actually being able to run a generator. Pipeline access and right of way. Like we learned the hard lesson at one point in 2019 that we got an operation set up on the well pad. We were taking gas that would otherwise have been flared, but then midstream capacity opened up, and so they were able to actually flow the gas into the pipeline to take it to midstream. So we had the gas taken away from us. And then on top of that, you have mineral rights owners. They're getting smarter about the fact that some of these operators are bringing in mining operations to mitigate flare, and that's producing revenue in the form of Bitcoin that's being mined. And they're getting involved in the conversations like, hey, you're using my minerals. I'm supposed to have a 12.5% royalty on any revenue produced by this. Typically it's at the midstream, but there are some intricacies, like since it was happening on the well pad, technically they didn't have to give them the royalties. And so now you have like mineral rights owners beginning to write like mining royalties on the well pad into their contracts. And on top of that, it's like logistically, this off-grid mining model is logistically a nightmare because you drill a well, you get the oil, you have the steep decline curve, and that gas, that archetype of gas, flared gas, is not sustainable or reliable in the long run. And so we always had the idea at Great American Mining that eventually, and so this is like,
it's not sustainable and reliable because the gas
is not
amount
consistent.
of capacity is declining.
Yeah.
The amount of power that you can generate at that site is variable because of that, but variable in a declining sense. That you basically have a mining operation at a site that can't be operated reliably at full utilization.
Exactly. And so the analog here, and like our thesis was like ultimately what actually makes sense. And so the analog would be like a midstream provider is like a power generator or utility on grid. And I think this is beginning to happen where we always said like what ideally makes sense is you go to the midstream operators who are basically aggregating all the gas from upstream and processing it and then sending it to utilities to run power facilities. It actually makes sense for mining operations to exist at the midstream and act as this sort of pressure release valve for pipeline capacity.
Like next to a processing plant.
Yes. And so I think I've talked...
Maybe describe a little bit about that there's pipelines from the well site going to the processing plant and then from the processing plant to the generators.
Yes. And so you have this upstream, midstream, and downstream, like the generators is the way I would describe it and understand it. And what actually makes sense is if you want to prevent flare upstream, what you really need is more pipeline capacity, because that's typically it's not every instance. There's some instance where you have to flare because they don't have access to a pipeline to send it in the first place. But there's a lot of situations where they're flaring because pipeline capacity doesn't exist. It's full. And so you just have this excess gas you have to burn off. So what actually makes sense is instead of logistically trying to plop down mining operations at these different upstream well pads, what you do is you just put a big sort of base load at the midstream, and you basically have this offset right at the co-location or the aggregation site of the gas coming from upstream. And when you need more pipeline capacity, if they're drilling more wells upstream on the well pad, you just simply divert some of the gas to the mining operation. You let the generators that are running the miners consume the gas, open up capacity, and prevent flaring upstream. And so we would call that like sucking in flare from the midstream is how we would describe it. And so I think on the off-grid side, that's where I would like to see things go. And I have talked to some miners who have clued in on that and some midstream providers who have recognized this and are beginning to implement that strategy. But that's similar to on-grid demand response, and where I think ultimately it goes is the power generators.
Basically it's a regulator of excess.
Yes.
And so I want to come back to this because I want to get the thoughts of like why sitting at the midstream versus more optimally at the point of generation for someone that is converting gas to power to then supplied to the grid of whether it's a balance between both of those points, kind of essentially providing regulation at different points in the power generation supply chain. But before that, I do want to just rewind on anchoring somebody that is less familiar in the space to two things. How you describe the function of Bitcoin mining in terms of what it is doing for the Bitcoin network, as well as the nature of power demand for the Bitcoin network and how it differs from all other sources of power demand.
Yeah, it's actually.
But then I want to come back after I kind of anchoring in those concepts. I want to come back to the discussion on, where power generation for Bitcoin mining might be most optimally set.
No, this is very fitting because I was tweeting about it earlier. Proof of work over everything, and I was quote tweeting Elon Musk, who tweeted out something about physics, like you can't fake physics, like nothing. You can't 51% attack physics, if you will. Physics is the truth, and so I guess that is the sort of reason that we use proof of work in Bitcoin mining. Like Bitcoin is this distributed monetary system, and the whole reason for Bitcoin existing is because we want to separate state and money, and we don't want central authority over the monetary system. We want a monetary system that anybody can audit, anybody can verify, and everybody knows what's going to happen when, in terms of how blocks are going to be produced and how much Bitcoin's going to exist on the market at any given point in time. And that's the function that mining plays, is sort of regulating the distribution of Bitcoin. And then on top of that, the facilitation of transactions on the network on a block to block basis. And so mining is sort of this melding of the physical and digital world using physics, in the sense that it's taking an energy source, turning it into electricity, pushing it through these computers that produce these hashes. And then those hashes basically create a market for block production. If you find a particular hash that is below the difficulty target, you present it to the network. The rest of the miners and the nodes say, yep, that's the hash that's below the target. You can add a block of transactions. They do that. You're rewarded in Bitcoin.
So there's a lot there, but describe what you just said, block production. And if a bunch of people have no idea what that means, it is enforcing the fixed supply of Bitcoin, as well as validating all changes in state, which are represented as people sending Bitcoin from
one address to another,
people all over the world, and ensuring that only valid transactions be processed.
Yes.
Actually.
And so that's the process. Why is mining important? Because to ensure that the system is distributed, decentralized, you basically need this process where anybody can contribute to block production by plugging in one of these computers that produce hashes. And that's the way we create a fair system. There's no central sort of authority who determines, okay, these people are trying to make these transactions at this given point in time. Let's just aggregate them in a block and put it on the blockchain. You don't want a central authority to it. You need distributed, economically incentivized actors to do that.
And you can't fake a joule.
No, and you can't fake a joule, and you can't fake a hash. And that's what you've mentioned, the 180x increase in hash rate over the last 7 years. That is a product of more people sort of entering this race of block production to hopefully produce Bitcoin at a cost that is cheaper than the market rate for which they could sell it right now.
And so that's describing the function of mining within Bitcoin. And but now I want you to describe a little bit in your own perspective of the nature of Bitcoin's demand for power and how it differs from all other sources of power in the market. And if you could, because one of the ways that, as we're thinking about names for the podcast, which we're still working on settling on, is thinking about what is actually happening. And you described it where basically there's energy in some stored state. It's transformed into electricity. That electricity is effectively converted to computation, which releases heat. And through that process of essentially creating computer or hashes derives from computing power, Bitcoin network is enforcing its fixed supply, validating currency transactions all over the world without a centralized third party, and it's separating effectively ownership of the network from validation.
Yes.
in a way that anybody can participate in.
Yeah.
But then if it's demanding some form of stored energy, converting that into power, now describe what makes the nature of Bitcoin's power demand you in the market, because it is a fundamentally new source of power demand that prior to Bitcoin did not exist. And realistically, when Bitcoin was very small, it demanded very little power, and that as it grows, the more power it consumes, the more relevant it becomes to energy systems, and the more it can potentially solve energy problems.
Yeah. And so I guess the nature of the demand for power from Bitcoin miners at any given point in time is contingent on a couple of things. Number one, how expensive or cheap is that power? Number two, how expensive or how much is Bitcoin worth at that given point in time? And running the calculation of your energy costs, let's add infrastructure and operations and all that into that, and the price of Bitcoin. Any given point in time, you're basically going to consume power if you think you can produce a Bitcoin for less than you could sell it at the market at any given point in time. So I think that dictates the demand for power from the Bitcoin network at any given point in time. With that being said, I think the interesting thing that Bitcoin mining brings to the world is demand for power sources that previously had no demand. And so in the example, Great American Mining, flare gas was something they were literally setting on fire because nobody wanted that gas because there was no ability to monetize it because it couldn't get to market, right? It was stranded energy, like out in the middle of these oil fields. And that's the beauty of the Bitcoin mining network, is that it brings a new form of demand to energy resources that for a very long time were simply just wasted because there's no way to monetize them. So I think Ross Stevens has written very eloquently about this, and many others, like Bitcoin mining is this pioneer species that
Brandon Quittem also wrote in.
Brandon Quittem, that can monetize energy sources that were previously unmonetizable. And so it brings demand for that archetype of energy that's existed for a long time, but has never been able to be monetized. And this is possible because the Bitcoin network is distributed. And so if you have the ability to generate electricity, the computers that produce the hashes that ultimately get you Bitcoin, and an internet connection. It could be a cellular internet connection. That's the thing. Miners, when they're sending their hashes to the network or a pool, it takes kilobytes of data. So you can use pretty low latency.
Significant amount of work at the site, but very little data transmission.
Yeah, when you're interacting with the network, you're sending kilobytes of data when you're sending your shares to a pool or to the network directly. And so that creates a beautiful thing where you can go and you can monetize these previously unmonetizable energy sources on site. So you bring the market to the molecule, is one of the things we would say at Great American Mining. And the network isn't dependent on any one individual miner having 100% uptime anywhere in the world because it's distributed. And so you can have this.
Explain that, because I think that's a really important concept, that it's functionally that miners are suppliers to the Bitcoin network, and that the Bitcoin network is the source of demand. It's basically aggregating demand all over the world, and then distributed suppliers. And just talk about like the that as a concept, and significance of it.
Yeah, so it's location agnostic, and since Bitcoin's a distributed system, you can have disruptions to individual parts of the mining industry, of individual mining operations, without disrupting the distributed Bitcoin network. The extent of this disruption, if it hits a critical, or not a critical scale, but a certain scale, is just slower block production. And I think that's
right. But like making that point, it's like if a hospital stops pulling on power,
yes,
the operation of the hospital
shuts down.
Now, if a Bitcoin miner shuts down, its operation shuts down, but the Bitcoin network continues to operate just slightly slower. And the actual operation that is generating is the source of demand is the Bitcoin network itself, which the miner is supplying. It's kind of it's a part of the supply chain, but it's not the actual end demand.
No. The end demand is the people looking to send Bitcoin from one place to another. Right?
Yeah.
And this is a beautiful thing. Hospitals, one example, Amazon Web Services, cloud data centers, the AI compute, particularly for model training, like they cannot have disruptions. They need consistent power. Or in the case of Amazon, if one of their data centers goes down, like you have websites that'll go down, like critical business infrastructure that will literally go down. Maybe they have some redundancies, but I think it's safe to say that they need significant amount of uptime and reliability. Whereas the Bitcoin network, an individual mining operation may want that uptime, but it's not critical to the Bitcoin network being able to facilitate
and I think, but there's another piece of that, which is that and you mentioned this before, but it's a functionally a purely economic source of demand.
Mm-hmm.
And in some form or fashion, but in a more derivative way, every demand for power is refining that power into some higher ordered good to ultimately have an economic incentive. But Bitcoin mining is essentially the least refined that has a direct monetization to money, not needing to refine it into something else to then deliver a good or service to trade it. And for that reason, it's this aggregated source of demand being the Bitcoin network, as well as this purely dollars and cents, Bitcoin and sats. Do I consume this power because all I'm using it for is to turn it directly into money, not some other good or service?
Exactly. Yeah. And it's a beautiful thing too, because Bitcoin trades 24/7, 365. It's extremely
without counterparty
liquid.
risk.
Without counterparty risk,
Well,
extremely liquid.
With pools, you have some counterparty risk.
Yes. And I'm sure we'll get to it, but like the pools have created payout structures, which are a problem right now, but where it makes it so you can get paid out every day. And so, yeah, you do have this stream of or revenue that you can convert to dollars when you need to immediately. And a lot of miners, I think, have really gotten smart about managing their Bitcoin revenue and inventory in ways that are advantageous for the long-term viability of their businesses. But yeah, long story short, Bitcoin mining is this demand source that is location agnostic and has the ability to be flexible in the sense that if a mining operation goes down, it doesn't really critically impair the Bitcoin network and the facilitation.
If it's more profitable for them to turn down, because it might be more costly to continue to run, then they have a direct incentive to do that.
Yeah. And we've seen that we just had the largest downward difficulty adjustment in, I believe, 5 years earlier this week. And this is a product of the heat wave that's been going.
Conspiracy theorists thought that it might be
maybe this is good
Iranian nuclear sites, but I don't want to go down that.
No, I think this is important though. Like going back to the first time I dove down the Bitcoin rabbit hole, and I think this is actually this sort of theme that we're pulling on here is indicative of Bitcoin mining becoming like a truly industrialized commodity producing business. Where when I was working at the Managed Futures Fund, we were following nat gas markets, WTI, power markets just generally. Like I found it fascinating because you could have geopolitical events or weather events in certain parts of the world really materially affect those markets. And we're beginning to see that in Bitcoin, particularly as more miners become engaged in demand response within grid systems. And so last week, earlier this week, we had the largest downward difficulty adjustment we've had in many years. It was negative 7.7%. And as you alluded to, there were many people that were pointing at the United States bombing Iran's nuclear enrichment sites and saying, oh my gosh, Iran was running these mining operations there. That's why Hashrate fell. And I think it's been very well known that Iran certainly does have a material amount of hash rate within its borders, but I think people were, I think it's clear because you can look at the ERCOT data specifically, but literally right around the same time that we were bombing Iran, the heat wave was starting to hit the United States and the Northeast and here in Texas. And it was just a coincidence that we were bombing Iran while that was going on. And what was actually happening, number one, we bombed nuclear enrichment sites, which aren't power facilities. And so like, it doesn't make any sense that if you're going to have something as high stakes as a nuclear enrichment site that you would co-locate a Bitcoin mining. It doesn't make any sense. They're not like actually producing power there. If you are producing power there, you probably want to spend it all on the enrichment. And I'm not going to make any assumptions there. But we had the heat wave going on here. And so miners that were engaged in demand response, the pricing signals that they were getting were, oh, it's too expensive to mine Bitcoin. And we're in this program that will pay us if we shut down and send our electricity back to the grid. And that's actually what has been happening over the last week. It's been 100. It's crazy actually coming back down here. It's been hotter. The heat in Jersey has been more oppressive than it is here. It's actually relieving to be here this week.
Yeah. Yeah. Last couple summers, totally brutal. This summer, more mild. You know, people get adjusted to it. But it is interesting that because one of the things that I mentioned, and when we're starting to see it, but I expect it to grow, is that when Bitcoin was very small, its demand for power was small. And the larger that it's grown, it can actually impact. It needed a certain level of scale to be able to actually be relevant to an energy system. And thinking about something like ERCOT, and I want to use this to segue back to that question of kind of where optimally, and my expectation is, I want your thoughts, is that Bitcoin mining will exist everywhere, but geographically, as well as at different places where there's underutilized energy assets. But if Bitcoin can effectively solve an upstream problem, in certain scenarios, a midstream problem, and then in the case of conversion to power generation for the grid, downstream problem. Now, my understanding is that Bitcoin mining in ERCOT is like 3 to 4 gigawatts, a functional base load, and that peak in the summer, which I'm sure we're not all-time highs, but either last summer or the summer before, we had hit something around 90 gigawatts of power. That 4 gigawatts, taking that offline at peak demand, is enough to provide not just a service, but relief to the grid itself. So how do you think, like, in terms of actually being value additive, that if you think about, you know, peak demand in Texas in the summer being between 80 to 90 gigawatts, if you were only drawing 100 megawatts power in terms of Bitcoin miners in Texas, it can't really solve material problems. But it's 4 gigawatts, it starts to solve a problem. If it becomes 10, it can solve problems more effectively. How do you think about how Bitcoin mining can solve problems, coming back to what you were saying of maybe the most optimal location might be at a midstream processing plant, but thinking about it relative to maybe that, why do you think that might be most optimal, but how do you think Bitcoin mining could be distributed to, in parallel or in tandem, solve different types of energy problems?
Well, to be clear, I think the midstream application is optimal for upstream energy producers that have problems with gas that they can't get into a pipeline. Like, I think it's optimal for solving that problem.
Now, does that essentially increase the economics of a pipeline to allow for more pipelines?
Yes, you can drill more oil, and you can get more gas to market and then monetize that gas that would otherwise be wasted, at least in the Bakken, where they have strict flaring regulations. And so if you flare a certain amount, you have to shut down the well pad, which means they really care about the oil at the end of the day.
I mean, gas is a byproduct, but if you can create a better, an actual economically sustainable path to offload the gas, then you can actually
produce more oil. And then on top
more
of that, you can monetize the gas, which wasn't possible before. So you're getting like compounded efficiencies there. But that's optimal for that specific problem. On grid, there's many other, like, I'm thinking of two things right now. I'm sure you've seen the charts of Chinese energy production over the last 3 decades versus energy production growth versus U.S. energy production
it's stagnation. Like flat, and one's not necessarily hockey sticking, but very linearly, aggressively ramping.
Yeah, like we need to catch up with China in terms of generation expansion and capacity expansion just throughout the United States. Texas has done a very good job.
I was gonna say, who's we here?
Yeah, well, still Texas, like demand's only going to continue to rise in Texas, and I think at a pretty steady clip as it becomes this bastion for free markets and enterprises that want to escape hellholes like California in the Northeast and actually build down here. You have foundries coming online in Taylor, I believe. You have Samsung building a foundry there. I think there's another one being built north of Houston, and you're going to need a ton of energy for that. And you have Tesla, SpaceX, all these companies coming to Texas to build physical things. They're going to need a lot of energy. And then on top of that, you have the residential, sort of the exodus from some of these states that are oppressive from a tax perspective or civil liberties perspective, and freedom-minded individuals flooding to Texas to sort of reap the benefits of the government and law that exists here. And so I think demand's going to increase. But back to Bitcoin mining, like, we need to increase generation and capacity. And I think Bitcoin, like, a lot of the problem with doing that is, like, how can you make the economic case? Like, it takes a ton of money, a ton of time. And how can you reduce risk while you're expanding generation at a fast clip? And Bitcoin mining's a perfect solution, a perfect way to de-risk energy generation, because you have an immediate buyer of the energy. And so, like, I think one of the prime examples of Bitcoin being this pioneer species for energy production is the fact that you can build a power facility and then put a mining operation behind the meter, so before it hits transmission lines, and consume energy there. And that's one of the problems that arises when you want to expand generation, is you can build a power plant, then you got to build transmission to actually connect it to the grid, and then so that the electricity can flow to consumers at the end of the day. And there's a time dilation there that exists, where you have your facility that could produce energy but isn't doing it because there's no transmission to get it to market. So Bitcoin miners can sit behind the meter on site at the place of generation and be that revenue producer for the generation asset before transmission's built out. That's one. And I actually have a cousin who runs a nuclear facility in Nebraska. I've mentioned this to you, but we were talking about it 2 years ago. I need to call him again, but he was describing to me a problem that he has. They've overbuilt wind capacity in the region out there to the point where it drives his prices negative. And
it's very costly to shut down.
So you have to keep the nuclear facility running. Prices are negative. You just have to eat that cost, essentially. And this is due to an overproduction of wind specifically, but Bitcoin mining helps in that case too, where if you have a Bitcoin mining operation behind the meter, and wind starts overproducing and your nuclear power becomes economically non-competitive because the wind is cheaper for people to consume, or there's just too much of a supply of power in that particular grid system, and you have to eat the cost of running negative prices. Bitcoin mining operation behind the meter, instead of eating those negative costs, you just energize the mining operation and make revenue from the mining. And so in terms of the importance of Bitcoin mining within the energy sector for producers specifically, I think in terms of expansion of generation and capacity, you have a buyer of first resort that de-risks the operation from a speed to revenue perspective. And then for generators that are already up and running and are running into these problems of negative pricing due to the variability of wind and solar production in their grid systems, like, you have this sort of economic load that you can divert your energy to monetize on the go.
You mentioned, and I don't have a clear mind of what the right framing of it is, whether Bitcoin's the buyer of first resort
and last resort.
last. It's effectively Bitcoin miners should, in theory, be willing to pay the least for power, but they're most capable of absorbing excess power or energy assets that are underutilized that could be generating more power.
Yeah. So what I just described in the generation expansion, put it behind the meter before transmissions build out, that's first resort. The nuclear power facility that has to stomach negative pricing, that's last resort. It's like, nobody's going to buy this. Prices are going negative because there's an oversupply. I need a buyer of last resort to come in and soak this up. And so that's when you have a mining operation behind the meter there on the back, and when transmissions sufficiently build out and the ability to supply that particular market is robust to the point where prices are going negative, it's like, all right, last resort, I'm just going to mine Bitcoin with this because otherwise I'm just eating costs.
Yeah, and of course there's cost of the mine itself as to whether or not it's economic, and that might be, or not might be, that translates to whether a site or a solution is actually viable, as well as what a Bitcoin miner would be willing to pay or not pay for power.
Well, this is ultimately why I think generators become miners, because when it comes to like controlling the cost, at the end of the day, it's a race to the bottom. And if you're playing this out over 5, 10, 15 years, power generators are going to have the most control over those costs. And
right. And I think that maybe another way to say that, I mean, I tend to agree, but I'm also on this journey of trying to understand better myself. And that's part of what this podcast is about, is any point further from where some energy resources is converted to power and electricity. The further you get from that point, the more cost that exists. And it doesn't necessarily mean that Bitcoin mining won't exist in places other than the point of generation, but that you're optimizing for cheap power, and that there would have to be some other economic reason where an asset could be monetized increasingly to justify it not being at the point of generation.
Yeah.
And that might be because there's a large substation that already exists, and it can be an energy arbitrage and turn off, and that there's a valuable, there's a reason for an energy system for a Bitcoin mine to exist someplace. But if they're optimizing for cheap power, that transmission lines are cost, right? And if you can help be a balancing to load closest to the source, that there's a very rational reason why it will shift that way over time.
Yeah, it's about identifying and taking advantage of all the different, and that's the crazy thing, as I've learned over the last 7 years diving down the energy rabbit hole. There's so many different types of arbitrage opportunities, like what we just described with the negative pricing and the expansion of generation before transmissions build out, like upstream with the flare gas. There's so many different ways to skin the cat again of arbing the cheap energy. So like at Cathedra, what we're doing in the TVA, it's a different form. We're not going straight to the power generator. We're going to the utilities that own substations that have excess capacity that's not being utilized because they were built decades ago serving large manufacturing facilities that, due to globalization, have since moved out. And so you built a 20, 50 megawatt substation thinking that you're going to serve this steel factory. And you were in the beginning, but ultimately just the economics of steel production were so that you had to export that process somewhere else.
And that's a great, like you brought up the idea of the pioneer species that Ross Stevens has written about, Brandon Quinton has written about, others, where it's like, it's the first kind of demand, and then it makes a place inhabitable, and then other species come. That's the idea of a pioneer species. This is what you just described, kind of consistent with that, where there was an energy asset, it was abandoned, and then a Bitcoin miner can come in and absorb that And then over time, maybe that industry comes back, or there's some higher value.
Yeah, and they're willing to
for the asset
overbid for the energy, and they come back.
An example, not exactly the same, but these Bitcoin miners aggregated large sources of power with high density. They were running mining sites, and then there's advancements in AI, and then these sites are perfect, and the AI companies are willing to pay more for power, and then there's a higher, better use than the Bitcoin mine, and the Bitcoin miners go somewhere else. But I think this idea where there's all this energy infrastructure, where say there might have been in the Midwest these 50,000 manufacturing plants are gone. Hopefully those, that manufacturing comes back, but Bitcoin miners can absorb that energy infrastructure, which then allows them to be maintained rather than decayed and have their value to go to zero. And so I think that that's, another very interesting dynamic that fits into this idea of the pioneer species, but in a different way. And one of the things I want to do on the podcast is go focus episodes on each different way that Bitcoin mining can solve a problem in an energy system. But one thing that you mentioned a little bit ago, not talking about the specific subject, but you talked about, Texas increasing in energy demand, and about how Samsung was building a foundry to manufacture chips. Texas, I believe there's one out in
Arizona.
As well. But one of the things that we'll explore in more episodes of the podcast is each kind of those sources of demand, as well as how Bitcoin mining can actually solve an energy problem or an inefficiency exists that creates a problem. One of the problems, and problem is a loose term and it's always a degree, but shifting the focus is talking about miner centralization. It seems to me, and I want to see if you agree with this, given the nature of where energy resources exist in the world, that the most decentralized and distributed part of the mining ecosystem is actually where hashes are produced. And then the more centralized are where the chips are manufactured, as well as where
the hash rate is
aggregated. So talk a little bit about, if we're shifting, we'll be diving into all of these subjects deeply, but trying to kind of set the table for the range of different things that we'll talk about through various different episodes. Talk about the points of Bitcoin mining that are more centralized than less, and how you see that changing or evolving, and why.
Yeah. So let's start with the ASICs, the chips. So what do ASICs do? ASICs are these computer chips in the same application specific integrated circuit. So it does one thing, and it does one thing well. Bitcoin ASICs, they do hashcash, SHA-256 hashing. Like that's all they do is run that hashing algorithm. You input some randomness, it outputs a hash, and that's all that these chips do. And
not to lose people, for the purpose of forcing Bitcoin's fixed supply, and validating currency transactions all over the world.
And so ASIC chips are like top of the line. Like to produce an ASIC chip is not easy. It's high risk, capital intensive, like very specialized, and there's only a few chip manufacturers in the world that can do it. Actually, really two right now.
Which two?
TSMC and Samsung. So, I mean, and really, even between the two, like really TSMC, Bitmain is the monolith.
Does Samsung produce a ASIC?
Yeah, the WhatsMiner they use.
Oh, WhatsMiner does.
Yeah, WhatsMiner uses Samsung's ASICs.
And the two largest manufacturers of Bitcoin miners, which include ASICs, are Bitmain
and MicroBT, which produces the WhatsMiners. Bitmain produces the Antminers.
And Bitmain sources their chips from TSMC.
Yes.
And MicroBT sources theirs from Samsung.
Predominantly from Bitmain, TSMC in Taiwan. As it stands right now, MicroBT, Samsung, and South Korea. That's where the chips are being produced, Taiwan and South Korea. And it's hyper-centralized, has been since ASICs came to market in 2013, 2014, 2013, I believe, maybe late 2012. That's when Bitmain launched the S9. We've had a bunch of competitors come to market, but really Bitmain's the Goliath in the room. The MicroBT's number 2. And funnily enough, MicroBT was started by Dr. Zhang, who was previously at Bitmain, and he designed the S9, which is considered the AK-47 of Bitcoin mining ASICs. This is an S1.
S1. I think we have S9s outside.
Outside, yeah. There's some rusty S9s out there, but they were produced.
Come by Bitcoin Park, you can pick one up.
2013, or maybe later than that. The S9 was like maybe 2016. And there's some of those S9s are still running today profitably if you have zero cost energy. It's hyper centralized, but the physical nature of these ASICs, like the chips, we're reaching the physical limits of how much electricity you can push through them to produce the hashes. And so this is something that has been talked about in Bitcoin mining.
You said that, but ultimately you want to be able to produce more hashes per unit of energy.
Yes.
That's the increase in efficiency.
And
but you're saying that the ability we're reaching the,
like right now you have 3 nanometer ASICs, people talking about 2 nanometer ASICs. Then you have one. You can't go.
And reducing the number of nanometers basically increases the amount of
hash.
The
efficiency, joules per terahash. It makes that go down. And we're reaching the physical limits. I believe, who knows if there's some order of magnitude improvement that could be made. I'm not, it's out of my pay grade, but like I'm pretty sure, like the point being,
and also say we're in theory reaching the physical limits of what the best manufacturers in the world are capable of doing, which is a very difficult thing to do.
Yes. And once you've reached that limit, though, it's been talked about in Bitcoin mining for some time, we may hit a point where you get what's referred to as ASIC commodification, where that's the problem with competitors trying to enter the market, is that Bitmain and MicroBT, they have access to top of the line chips from a nanometer perspective. From the smaller the nanometer, the more efficient you can be. And so the risk of going out there, and we saw this with Intel, and trying to produce, I believe they produced like a 5 nanometer chip, and it took them 18 months. By the time they got to market, Bitmain was out with a 3 nanometer chip. And you're just not competitive there. Like
what governs the amount of power that a Bitcoin miner can pull? Is it the number of ASICs, and then each ASIC has a certain amount of like the heat rate that it can support, or just explain that? I don't.
Maybe above my pay grade too, but like, yeah,
we'll get an expert to come on to like talk about.
You have joules per terahash that can produce. So you have, back at Great American Mining, we could put, I believe, 200. It would be 200 M20Ss, MicroBT, and WhatsMiner M20Ss in a shipping container, and that would pull like 700 kilowatts of power from the generator.
Do you have a rough order of magnitude of, like, say, like a single ASIC, how much power it would be capable?
So this is a single ASIC on a board. This is, I believe, an S20 or an S19 or an S21. This is 5 volts. This one is running on 5 volt power right now.
But can you provide some like order of magnitude to help somebody understand like the density relative to, say, like a computer?
And so, to a computer, it's orders of magnitude higher. But I think a better way to frame is like, in 2017, I believe the joules per terahash rate was literally over 1,000. Might have been like 1,200 joules per terahash on average across the Bitcoin network that the miners are pulling today. It's like 15. So we've made top of the line miners pulling like 15 and a half joules per terahash, I believe. So we've had
basically more hashes per unit of energy.
Yes.
Becoming massively more efficient.
Yeah. Yeah.
Now, describe 2 things. Why it's as centralized as it is, and what the current risks of that centralization are. Because MicroBT has increasingly taken share from Bitmain, but Bitmain and MicroBT probably have in aggregate 95% of the market.
Probably more than that, yeah.
Okay, but so what is preventing greater decentralization, and then what the present risk of that centralization is to the Bitcoin network?
I think it's access to foundry space, right? It's expensive. It's risk, it's capital intensive, and it takes time. And
that is like effectively competing with somebody creating chips for GPUs for AI data centers?
AI, for Apple, for whoever. You're competing with everybody for space on the foundry floor to produce your chips.
And if you're a large Bitcoin miner and you're planning a site, say a gigawatt site in Texas, you might not have reliable access to be able to get chips.
Well, that's not your job. That's Bitmain's job, right?
Well, no, but what I'm saying is if you're a Bitcoin miner and you're planning the site, it's predicated on being able to actually get chips from Bitmain.
Yeah.
And that if Bitmain decides not to supply you because they're centralized to supply somebody else, that's a source of.
Yeah. But I think like a layer down, like why aren't there more chip manufacturers? Because it's not easy to get on the foundry floor. And I think MicroBT and Bitmain have been in the game for a long time and have proven to the foundries, like if they come to me with a chip design, like they're going to have the money, they're going to make a lot. And
so like, for example, Intel tried to make a chip, correct?
Yeah.
And they spent years, they actually delivered one, but then shut down the program.
Yeah, because
there are companies that have a lot of money that have a lot of.
And this is where you begin to wander into the competition between the US and China, specifically from a intellectual capital perspective. Like their chip design just wasn't as good as MicroBT and Bitmain's.
So they were effectively bringing a chip to the foundry that wasn't.
And they were using their own foundry. Intel has their own foundries, and just didn't compare from a.
When they were actually taking it to market, the Bitcoin miners were saying, "No, we need something of either MicroBT or Bitmain's."
Yeah. Now you have like Arduino and Proto, which is the block company. They're going after it. And
so there's effectively the capability of the manufacturer and their design, as well as access to the foundry, which is predicated on the capability of the foundry, but then also the foundry's
availability
and perspective as to whether you have the capability to actually execute if they gave you
or if you're going to be a long-term customer, like are they going to give up foundry space to you knowing that you're going to come back year after year and there's going to be demand for your product? Like that's the risk the foundry takes.
Is there something about Bitcoin and its effectively simplicity in terms of its operation, like what the ASIC needs to do, that like there's less diversity because it's homogenous?
Again, above my pay grade, but from what I understand, no, because any ASIC, whether it's a Bitcoin ASIC or some ASIC for some other application, does one thing, application specific. So from my understanding, ASICs, no matter if they're Bitcoin miner or running some other type of computer, just doing one thing. And that's the whole point of producing an ASIC chip, is just you want to be ultimately efficient at doing that one thing. In Bitcoin mining, it's just producing the hashcash SHA-256.
So there's no fundamental reason why the development of Bitcoin ASICs should be any more or less centralized than the development of any other ASIC.
Yeah.
And again, these are subjects that we'll dive into deeper, where we get
I'm not the ASIC expert. I know enough to be dangerous.
We'll get the ASIC expert in to talk about these things at greater detail. But then the second question of there's the risk to the manufacturer, but then to the Bitcoin network itself. Maybe describe risk, or if there's less risk because of the function of ASIC manufacturers. Just what's your view of what risk does this piece of centralization in Bitcoin mining ecosystem represent to the network?
I think we have to go back in time to 2016, 2017, when Greg Maxwell discovered that Bitmain had a backdoor in their ASICs called amp lead, where they could remotely brick machines if they wanted to. And so when you talk about risk of
I mean, that's a
manufacturing
serious risk,
centralization,
both to the Bitcoin network, but also to somebody like ERCOT. You know, if they had 4 gigawatts of power drawing on the ERCOT grid, and a Chinese manufacturer could say
brick, yeah,
that 4 gigawatts comes down all at once.
Yeah.
But then to the Bitcoin ecosystem, if 80% of the installed base of machines that are hashing could also be shut down. Now there's a limit to what the actual difficulty adjustment can be in any one epoch.
Negative 75%.
Okay, so it's in line with, you know, say if somebody had 80% market share, but how was that resolved?
Called out, and it was never.
Was that like software, firmware, or like
firmware?
Yeah,
I believe. Like the firmware was remotely like pinging back to central servers and if the central server wanted to, they could remotely shut down the machine. Is how I recall it. This was many years ago. I didn't even know about it because
that was like right before.
And this is right around ASIC. Like another
2016
thing
was right as I was like getting interested in Bitcoin.
Yeah. And then ASIC boost was like another thing. It wasn't necessarily a backdoor, but it became apparent that
it seemed like just like a marginal economic advantage, which may skew things over time, but less critical to the actual operation.
It just gave
Bitcoin
it gave Bitmain essentially
and also maybe to connect this idea for people that are less familiar with Bitcoin mining is that if 80% of the network came offline at one time and the network state was assuming there to be 5 times the amount of Bitcoin hash rate, that the Bitcoin network would take like 5 times longer to validate transactions and would create a lot of congestion.
Yeah.
Okay.
Yeah. So that's one of the risks. But then I try not to dwell on those risks too much because, again, going back to the fact it's become
What about dictating rules, though? Dictating rules of the
consensus
network.
Rules?
Yeah. Is there...
I mean, you need to get miners on board, I think, to a certain extent.
But does the concentration of manufacturing of ASICs?
No, I don't think so.
Okay. Okay, so then let's shift because we want to be efficient. The other source of primary centralization in Bitcoin mining is the pool side. Describe quickly, like somebody was 5, what a Bitcoin mining pool is, and again, anchoring everyone in this idea that, because it's easy to get lost in these rabbit holes, which is Bitcoin miners producing hashes, those hashes as a network, forcing Bitcoin's fixed supply, and validating currency transactions. Where do pools fit in, and describe the state of centralization and, in your view, the risks that are created there?
Yeah. And so I'm sure many of the people listening to this are aware of Bitcoin folklore of people plugging in their MacBooks in 2009, 2010, 2011, downloading the Bitcoin software, hitting mine, and mining blocks themselves. Like you hear the stories of OGs who simply downloaded Bitcoin on their computers, mined, and accumulated large amounts of Bitcoin. And that was the case back then. It's not the case now. As we described, Hashrate has gone up 180x over the last 7 years. And so what has been introduced in terms of a risk for individual miners is what we call a variance risk. So as more mining nodes join the network, that's more competition to produce blocks to get the reward. That ensures that any individual miner, their chances of mining a block goes down significantly. And so that means that your payout variance increases. So the frequency with which you find a block and get rewarded for that block goes down significantly. And the way to solve that problem is to aggregate hash rate. You get a bunch of these smaller miners and now large miners as well. They basically aggregate their hash rate in what's known as a Bitcoin mining pool. And that mining pool is essentially tasked with aggregating the hash rate. And then you have all these individual actors within the pool producing hashes. One of those actors will find the hash that enables them to add a block to the ledger and get the reward. And the pool does the job of basically accounting for who's pointing hash at their pool at one point in time, how much hash rate, and how much of the reward each individual miner gets based off of the amount of hash rate they're pointing at the pool. So pool exists to increase variance. And so when you hear of individual miners mining their own blocks and building a big Bitcoin stack in 2009, 2010, that doesn't happen anymore. It's a bunch of individual miners pointing at a pool. And even if your individual miner finds a hash, you're basically saying, I'm going to lower my variance by pointing at this pool, and I'm going to split the reward among all the miners pointing at that particular pool.
Yeah, such that if I'm a miner and I represented 100th of the network, I would solve a block, like one block a day.
Yeah.
But if I represented 1,000th of the network, then it would take me several days to potentially find a block on my own. And if you kind of go smaller and smaller, and as the Bitcoin network gets larger and larger, and while there are exceptions, it becomes more difficult to be a large enough percentage on the network to reliably
get paid out.
If you have expenses that you're paying out in the interim, it might require you to have more capitalization, more working capital on hand, and just creates a strain operationally. And so for that reason, rules began to emerge to allow people to effectively get paid out more regularly, reduce variance, kind of make it's difficult to capitalize a mine as it is, reducing the working capital requirements potentially of a Bitcoin mine. So now describe the current state of centralization in mining pools and why, in your view, it exists.
To do this, we have to go back in time as well. When pools first came out, the predominant payout scheme was called PPL and LNS, pay per last N shares. And basically, in that mining pool payout model, you would point your hash at a pool, and then whenever that pool would find a block, you would get your commensurate amount of the reward, and you get paid out when they found the block. Like when they would find a block, and then you get paid out from that reward. And as the network grew and more pools came to market, like the variance of individual pools began to grow and extend as well. And so the predominant model that has really taken over within Bitcoin mining pools, the payout model, is FPPS, full pay per share. And essentially what full pay per share pools have created is a system where they say, point your hash rate at our pool. We'll do like a moving average of how much hash rate, how much blocks we produced, and we'll pay you out a consistent amount every day. We'll pay you out once a day based off of that moving average. So you have more consistent revenue. You're not beholden to the variance risk.
Functionally, pools help reduce variance, but then the FPPS, the fixed pay per share, further reduces variance by giving a miner a predictable daily amount of revenue. Why has that caused centralization?
So that's so you have two trade-offs. PPLNS, what was predominant in the early years of pooling. The trade-off there is you're going to, as an individual miner, you're going to get like the full reward of that block that's mined, because it's not as relevant right now because there's not a lot of fees. But like if we're in a high fee environment and the variability of block rewards is pretty high because fees are variable from block to block. Like PPLNS model, like if your pool mines a block with a very high fee, like you want to get that whole reward. And so like that's the trade-off you make in PPLNS is like, I'm going to get the whole reward of that block, but I'm going to stomach more variance because it's not like that pool could have a string of bad luck where instead of finding 3 blocks a day, they find 3 blocks over 3 days. And so you're getting less consistent payouts, but you're reaping the full reward of those individual payouts. FPPS, fixed pay per share. Again, since it's the moving average of the individual block, let's say the pool mines a block with a fat fee, like they're just going to use the moving average in their calculations. You're going to get paid out and you're not going to get the full reward, but you're getting paid out every day. And this creates an accounting problem for the pools and a capital problem specifically. So for the FPPS pools, the fixed pay per share pools, to be able to do this, what they need is a big Bitcoin treasury that they can actually use. They essentially use as a credit line. They're absorbing the risk. They're absorbing the variance risk as the pool. And so you need a big Bitcoin treasury to pull from to consistently pay out, because even as an FPPS pool, you can have strings of bad luck where your variance increases and elongates. And if you're running an FPPS pool where you have a pretty long string of bad luck, you could run out of Bitcoin in your reserves and you cannot pay out. And so that over the last 2 years, it's become clear that mechanism has become a very centralizing aspect of the Bitcoin mining pool industry, because what we found is that last year, Matt Corallo and others started ringing the alarm bell. It became clear, and a lot of on-chain analysts like OXT and 0XT were basically observing that the block templates of different FPPS mining pools were exactly the same. And so essentially what was discovered is that you had a number of FPPS pools run into that treasury problem where they didn't have enough Bitcoin to pay out. And so they were forced to go hat in hand to Antpool, which is essentially a subsidiary of Bitmain.
Basically, mining pools that were attempting to deliver the product that they thought would allow them to acquire miners as customers, being able to pay out a consistent amount each day, were not well capitalized, and they were absorbing the financial risk, and then ultimately they got exposed. Whether they went belly up, they realized that they couldn't absorb that risk, and they went up the food chain to companies that had larger balance sheets.
Mm-hmm.
And then essentially it becomes a game that if you are not, I don't know if irony is the term, but it's like the same risk exists with these larger guys that are just aggregating more hash rate. It's like they're bearing this financial risk, and they could be exposed as not being financially solvent should a stretch of bad luck emerge for an extended period of time.
In the case of Ample, I think it would have to be a very, very long,
and we'll go
statistically
into,
impossible.
Yeah, and I'm going to spend time digging into this, like the differences between a paper last and shares, different forms of that, fixed pay per share, some of the economic incentives that might not be as well understood in terms of how you're basically trusting FPPS pool in terms of what the pool is actually generating, how fees are actually accounted for, distributed. We'll go into that in other episodes, but just articulate what, as a percentage basis, does that ecosystem look like to not lose people in the weeds.
The last time I saw I think to describe it more thoroughly, Ampool essentially a subsidiary of Bitmain, and over the course of
that's the point of centralization, is that these entities are related.
Yeah. They have a large Bitcoin war chest. And this is actually, when it comes to this pool problem, I don't think we're going to solve it here on this episode, but maybe we can do another one where I think when you look at pools if you think Bitcoin mining, just plugging in ASICs, and running them as an operation, locking down the energies, competitive pools are terrible businesses.
So people say this, pools are terrible businesses, but they are necessary to the operation of Bitcoin mining. And so one of the questions that I have is, it's maybe it's just a cost center to a business, but is it specialized enough to merit being its own business? And
I don't think so. The switching cost is zero. Like that's like
you don't. I mean, what I'm saying, you don't. It's a necessary. Like in order to mine, you essentially either have to be your own pool, or you have to join a pool. The pool function is critical. So, how can the pool business be a bad business if it's critical, if it's delivering both the service and being critical to the
because you can just
Bitcoin mining?
I mean, I think Ampool is a great example. They can just like set their costs such that you can't compete, right? Because they have this large, and so this might
because they're well capitalized.
They're extremely well capitalized. Like they have a large Bitcoin treasury. They have the hardware business. Essentially,
but that doesn't say that being a mining pool is a bad business. It just might say in order to be a good pool, you need to be very well capitalized. If FPPS is the right model, which I have questions about myself.
I don't think it's the right model, but I do think.
Okay, go on. Yeah.
Like I think looking at Bitmain and Ampool and their relationship, I think that's something people should really pay attention to and try to internalize. It's like you have this behemoth of Bitmain and their hardware sales, which is an incredible business. Cash flows a lot. Like, and
are they anti-competitive? Bitmain, just going back to the like, are they actively in the background trying to prevent other?
I wouldn't be surprised. I mean, I don't know for sure, but just if they're economically rational actors, I wouldn't be surprised if they are
preventing others from getting access to the foundries that they work with.
Yeah.
All right, that was just an aside, but sorry, I didn't mean to distract from the.
No, I think like running a pool, like you may need another like pools. I think we need to rethink like how pools come to be and how they operate. Like, is a pool a loss leader for somebody doing something like basic manufacturing or the Bitcoin exchanges? Maybe they should maybe they should be running pools to some extent, just as a way to decentralize. Like if you're an exchange and you're thinking about the long-term viability of your business and that sort of the prerequisite for that long-term success is Bitcoin being sufficiently decentralized and block production being decentralized, like doesn't make sense for you to spin up a pool to give people an option to, and I'm not saying this is the right answer, but just like thinking through this, like pools as a pure play business model, I don't think makes sense. Like you need another part of that business to sort of make sure it's well capitalized. And historically, we've seen this with Bitmain and Ampool via the ASIC sales, and then other pools like Luxor and Brains with firmware that makes the machines more efficient, and they charge a cost for that, and the cost is worth it because the efficiency gains are such that you will pay a fee for it and you get revenue that way. Or do we just need to completely rethink it and how, like what businesses should be spinning up pools to ensure that there's sufficient distribution of block creation between different actors? Does that make sense?
Yeah, that makes sense. And then to provide the most summary level view, we have actually Antpool that's based in China, right? And they're basically
saying, hey,
but I want to connect this for people that there are probably, based on what you said about Matt Corral and others who realize, how are we doing on time, Logan?
We're good.
That Antpool is essentially a proxy for 10 or so other pools, such that you're looking at those other pools and
they look like individual pools, but they're really a proxy for Antpool.
They're really a proxy for Antpool. Antpool's creating the templates. But so if you add up Antpool and the other pools,
it's like 60 to 70%.
And then Foundry which is US based.
Yeah, so it's not 60, it's probably like 50 to 60, yeah. Yeah, 50
to 60, maybe like 50. Foundry is like 25 to 30%.
Yeah.
And then Marathon, which is a solo, but a large scale miner.
You have other, which is around like 12.
So 3 functional pools, including one solo miner, and I know that very other small miners use Marathon's pool, but functionally it's a pool of one. That 3 pools represent about 90% of the hash rate. What is the present risk to the Bitcoin network functioning that comes from that?
So probably going to sound controversial, but I think 0. And again, going back to
no, but like describe why you view it as 0, but
because the switching cost is.
But then make the other argument.
I think it's 0 because the switching cost is 0, and if push comes to shove, we've seen this already in Bitcoin's history. In 2016, there was a pool called Ghash that was ultimately a victim of its own success. It aggregated as a single pool 55% of the network hash rate. People on BitcoinTalk.org and Twitter were like, yo, Ghash has 55%. This is a threat to the network. If they wanted to 51% attack the network, they could. And within days, it fell from 55% to 20%. And over the course of 18 months after the alarm bells went off, Ghash was out of business. So miners, individual hash owners that are economically incentivized to ensure that their golden goose isn't killed by centralization reacted to those centralization pressures.
Right. So I get why, it's not in the interest of mining pools or miners to 51% attack Bitcoin network. That would be putting at risk the thing that they exist.
No, but the real risk is you could have censorship, or they could try to reorg via 51% attack too.
But what about the angle of the three mining pools all being on the same page about consensus changes that are not hard forks?
See, this is where we get into like murky territory of like what actually is needed to, like, what actors are needed to actually get a soft fork, a change into Bitcoin. And that's like block size wars. What was it? Was it bit 91? Was it bit 148?
But in that case, that was actually a non-backward compatible change. I'm talking about in the block wars, increasing the block size to 2 times you would have forked off the network.
Well, Bitcoin Cash did.
Right. But that presents a different dilemma versus a soft fork. And if all 3 of the large mining pools agree on what change should be, and they're not forking themselves off from the network, then if you're a miner and you're hashing, you functionally can't switch between if there's collusion.
And this gets like who dictates the rules, right? Because like if you're
but like as an example, let me like throw a different scenario. Say Bitcoin Core wants to merge a soft fork, and 3 mining pools agree. Is that a risk?
Could be, but what if like economic
and I
actors,
say a risk to like a relatively few number of people.
You would need buy-in from other actors too, like exchange, like big economic actors that aren't mining, like exchanges and people that are transacting a lot on the Bitcoin network to download that node software. Like you could see a scenario where,
but it would be backward compatible, right? And the miners would be enforcing the rules, and that would be the longest chain. Anyways, we'll dive more into these topics.
I'm trying to think through this because again, going back to like BIP 91, BIP 148, like what was the actual sort of forcing function for SegWit getting implemented into Bitcoin?
I mean, that was.
Like, is there a scenario? It's backward compatible, but like let's say Coinbase says like I don't like this or River or Strike combination of all those guys. You have like this battle between these large economic transactors and the miners. Like could,
I mean, I think that my understanding is they would continue. They wouldn't have to change anything. They would be accepting all of the transactions that are on the more restricted as.
but even
as
if it's
valid.
backward compatible, nobody's running.
But if the mining
the
pools are
software.
advancing the longest chain,
Yeah, but like if nobody still, if it's back,
yeah, maybe there's not a functional.
there's nobody using it.
Yeah, that would de-risk it.
Yeah,
Like, hey, if
you can
if nodes aren't transmitting transactions that conform, but then that would kind of.
just that they just never download the version. Like, and then we get into all like sort of rough consensus dynamics of like somebody's actually got to build, write the software that the miners want, or that core wants, or core is like core is not some centralized entity.
All right, I'll shift the question.
This is where like the beauty of Bitcoin rough consensus comes in.
Yeah, and we're not going to solve all the knowledge base of Bitcoin in a single episode, but one last thing on this piece, and then we'll wrap up, which is it's not in the interest of Bitcoin miners, the ones that, like, if you think about the supply chain, it's some natural resource that is storing energy, being converted to electricity, that's creating a hash that in aggregate is enforcing Bitcoin's fixed supply and validating all currency transactions. Those hashes are pointed at a pool, and blocks are processed during the fixed supply. The Bitcoin network is working going forward. It's not in the interest of the miners actually producing the hashes that the pools are centralized. What in your mind changes the dynamic that would create a scenario for greater decentralization?
I think stuff like this is great, where you have sort of at-home mining, and as we reach ASIC commodification and the waste heat can be used for services like heating water in your house, using the waste heat to heat your house itself, that acts as like a natural.
But is that a view that, if Riot is working on a gigawatt site, that large scale Bitcoin mines are ultimately long term not as viable, and that
like I think like Riot, like I love everybody at these companies, but like at the end of the day, like
I'm just saying, if this is how Bitcoin decentralizes, it would decentralizes from the point of centralization as it relates to pools, then that would suggest that any Bitcoin mine of scale becomes less competitive for some reason that I couldn't gather, if the cheapest way to produce a unit of power is with large power plants.
Say that again?
That the cheapest unit of power is at scale with a either combined cycle turbine or a nuclear power plant, or even something like a large solar generator.
Yeah, at scale, they're going to be the cheapest, but like in the waste heat example for like at-home applications, like you're basically using Bitcoin mining to lower your month-to-month electricity bill and actually produce some revenue. Whether or not you're willing to stomach the variance is up to the individual, but I think what's most important is we can dive deep on the pool stuff and the industrial sized miners, but I think what I care about most is the decentralization of hash rate ownership. And as many, like, you're going to have obviously a spectrum of people owning one ASIC chip, like 1 terahash, to multiple tens, dozens of exahash. But as long as sort of distribution of individual owners across that spectrum is robust, I think it'll be sufficient to ensure that mining is decentralized at the end of the day. And
yeah, we'll have to explore this more, because explore this more because
It's like Tyler
if that
Stevens.
hash rate continues to naturally decentralize because energy is distributed all through the world, it seems like there's a disinterest or there should be a disincentive of all this very distributed hash rate pointing to a regulatory and otherwise censorship prone points of centralization being pools. That there would almost, and again, I want to explore it. I don't know what it is, a natural forcing function for miners to realize that there's an interest and an incentive for pools not to be nearly as centralized as they are today.
And going back to what I was saying earlier, like maybe it's not even the mining industry that comes up with the solution. Maybe it's some other sort of actor with a ton of skin in the game that recognizes this as a risk and has a profitable business and decides to spin up a mining pool to counteract the centralizing factors. Like I completely, like I don't have the answers to this, but I do think I've identified at least one thing, which is like we need to completely rethink how mining pools are like come to market and how they operate.
Yeah.
And then we're getting a bit doomerish here. It's important to understand these risks and where the centralization lies. But ultimately, at the end of the day, I think the incentives of Bitcoin as a project overall and individual actors within a mining ecosystem are aligned to the point where the problem will be solved. I don't know exactly what the solution is, but I'm just confident in the economic incentives. And as Bitcoin continues to increase in price, those incentives only get stronger. So
right, and that's something that we're going to talk about as well on other episodes. Like you said, the incentives of Bitcoin. And I think that if we think about just this first episode and where we plan to take this show, part of TFTC, is exploring kind of the entire value chain down to the molecules. From the molecules to the conversion of power, how Bitcoin how Bitcoin solves real world energy problems, how that changes as Bitcoin's demand for energy scales, why it won't increase in energy demand over time, or what the drivers will be, how that will evolve. Points of centralization, how Bitcoin mining works, of past the point of natural resources being converted into electricity, and the role of ASICs, the role of pools. But one of the things that I found, the legacy energy industry struggles with, or someone like a grid operator or legislators or regulators, is all this power demand sustainable? And I'm not talking about from an environmental perspective. I'm talking about from
are people going to want a Bitcoin mine 10 years from now?
Yes. And what causes that, and will it be sustained? Because if you develop, say, as a grid operator, an energy reliability strategy around 4 gigawatts of power growing to 8, growing to 10, growing to 20, and there's the possibility it could all go away, that's a source of risk. And what you just described was, you said, if price continues to go up, then all of these other things will follow. More demand for power, more decentralization, more entrance. And I just want to connect for the audience, and all the Bitcoiners know this, but it's that price increasing is a function of more people deciding to store their value in Bitcoin. And the thing that holds it all together is Bitcoin's fixed supply and its ability to operate in a way that is resistant to censorship, which is dependent on progressive decentralization at every layer of Bitcoin, such that so long as those two things hold, that Bitcoin's fixed supply is enforced and it remains permissionless and resistant to outside censorship, all those things happen. And those are the things that we'll just discuss and explore in greater detail. But knowing that it's all anchored to the monetary side, because it's kind of a turtles all the way down problem. And I want to kind of get your thoughts on this as kind of a concluding thought. And I'll have one last question, which is the thing that ties the demand for the hashes and the demand for power comes back to Bitcoin and the incentives of the Bitcoin network. Just talk about the incentives of the Bitcoin network itself and the fixed supply and its downstream impacts throughout the mining and power dynamics.
Yeah, and going back to what I said in the beginning of the episode, Bitcoin is not even an attempt. It's successfully separated money from state. So Bitcoin exists because Satoshi recognized that we keep running into these problems societally because governments and central banks can print money at will. And there needs to be a market response to the centralized control over money. And that's what Bitcoin represents. And so there's a ton of value in being able to successfully separate the function of money itself and the control over the units of that money that exists at any given point in time. And so that is what Bitcoin is we finally figured out a way to get the central authorities out of money. They're not meddling with it anymore in Bitcoin, which is incredibly valuable. There will only ever be 21 million, and people can have certainty that if they store their value in Bitcoin, their slice of the overall pie, even though it's very divisible, it doesn't mean you're producing more Bitcoin. Like if you own one Bitcoin, you own 1/21 millionth of the network into perpetuity. And there's a ton of value in having that certainty as an individual, as a company, as a government, even. And so that is essentially what ties all this together, is having that certainty that if you store your value in Bitcoin, it's not going to be debased. And as more people recognize this, it just perpetuates the feedback loop that you just described. And that is worth preserving. And people who are storing their value in Bitcoin will fight to ensure that those properties remain distributed so that the money cannot be meddled with in the future.
Yeah, and so it's like one for episode 1 parting takeaway for if you were an energy professional who doesn't understand why there's 4 gigawatts of power being drawn in Texas to mine Bitcoin and 30 gigawatts globally and get lost in hashes and ASICs and mining pools, the reason for its existence and the reason why it will be sustained is Bitcoin delivers sound money. The fixed supply is the anchor of that. It is solving the problem that every other form of money is dependent on trust. And through this function of mining is how the Bitcoin network incredibly enforces fixed supply in a trustless way without reliance on a central third party. But then for the Bitcoin miners and the people that are well immersed, is that all of that only works because of decentralization. And that if there's complacency of points of centralization, even though there are economic incentives that will dictate progressive decentralization, that only happens by individual actors within the network responding to incentives that contemplate that idea that points of centralization are not just risks to the network, but they are risks to the individual actor acting in their own self-interest.
Yeah. And so that's complacency and apathy will, if you're a miner, ruin your business in the long run, because you'll invest in all this infrastructure and you'll put all this time and effort into it. And if you get too complacent, too apathetic, and you just hand wave like, oh, this is okay. And Bitcoin becomes centralized and people are easily able to push changes that increase the supply or do something that makes it harder to run Bitcoin.
It distorts the economic incentives.
Yeah, you're basically just setting your capital on fire, because as an individual saving in Bitcoin, if that happens, I'm like, oh shit, like back to gold. Like and that's why, like, I'm sorry if it was like hand wavy and a little bit flippant earlier, but like I do believe the incentives are strong enough and people will be forced to reckon. And that's what we saw like in the block size war in 2017. When things are threatened, people react. And we saw it with Ghash in 2015. Like that, like we enter these periods where you have relative peacetime. But in my experience, being in Bitcoin for 12 years, whenever something controversial or something, a threat to the sanctity of Bitcoin, the protocol, and how it operates has ever arisen, like the economically incentivized individuals leveraging Bitcoin or involved in Bitcoin, like stand up and say, no, like you're not doing this.
Yeah, the threat needs to present itself in a lot of cases for, and it to be clear and present for a real immune response to kick in, while at the same time everyone's acting in their own self-interest, and there's a natural tie-in to de-risking yourself from other counterparties.
Yep.
Whether that's storing Bitcoin with an exchange, and that might mean having other exchange options or having more self-custody options, or whether you're tied into a certain vendor, or on the mining side, being tied into a pool, or having limited options to shift around, or who you are sourcing from in terms of a supplier. That throughout the ecosystem, everyone has an incentive to be less reliant on central points of failure.
Yeah.
All right, last question. 2 subjects related to energy or mining that you're most interested in us diving deeply in on this podcast, and then give me your top 5 wish lists of guests.
Okay. At home mining, like waste heat. I think people are sleeping on that trend. Tyler Stevens, and what they're trying to do. Like he wrote the book with brains on waste heat. Like the stat he threw out earlier this year at the Nashville Energy and Mining Summit was mind blowing. If you take 2% of the HVAC market globally and you successfully convince 2% of that market running HVAC systems to incorporate Bitcoin mining, you would like double the hash rate overnight. Just like that's that minute market share. Like
we'll get Tyler on to, so he'll be one of your top 5 then.
Incorporating mining into the home applications, basically subsidize your energy cost by producing Bitcoin. I think it'd be massively beneficial to decentralization of the network and really hash rate ownership overall. And you can think of like HVAC, like maybe individual HVAC companies run pools where their customers are putting their hash at the HVAC pool that they're using. And that's how you get mining pool decentralization. That's like at home, sort of like home application of mining using the waste heat, something that I'm very excited about. And I think we've reached a point of ASIC commodification where you can begin to build viable businesses around. So that's one. The other would be the midstream problem. I think like getting a midstream operator on here, hopefully one that actually understands Bitcoin mining and is like on top of it, like how that actually works. Because it was a thesis we had. I talked to some people that are saying that that thesis is being validated and they're actually doing it. And I think at scale, that would be massive for the natural gas supply chain and Bitcoin mining overall.
I've got some ideas of people that the Bitcoiners would have never heard of. So
yeah. Top 5, get Tyler on. Toby Rice from the EQT, the biggest natural gas producer. I had the pleasure of sitting out at dinner with him like 2 or 3 years ago. And
I don't know him.
He's
where is he on the Bitcoin spectrum?
He was this was like peak 21 craze. So he was talking like Shiba Inu and like meme coins and all. I was like, just focus on Bitcoin. That'd be a good one. Chris Wright. Is that
an FBI?
Chris Wright was the FBI. I always get them mixed up. Chris Wright, Department of Energy. I've had him on my podcast a couple of times in the past. It'd be great to catch up with him.
Is he the Secretary of the Energy?
I think he's, yeah.
Or Secretary of the Department of Energy.
Yeah. Elon, you got to get Elon. I mean, Jesse Pelton, maybe like Jesse, 1 degree away from.
I want to do
I'll admit,
I want to do a residency with Jesse on like on the physics of energy.
Yeah.
And then how that comes through Bitcoin.
Gotta
mining.
get Jesse. And then Nick Gates, I think.
Nick is priority power. He's
I think
he's within my handful of go-to people as I'm trying to understand the grid and energy systems, energy markets. He's one of my go-tos.
Yeah.
And then, he always he helps sharpen my views of everything around Bitcoin. I feel like I've helped him understand Bitcoin better.
And then I don't know their names, but one of the founders of an SMR company like Oklo.
You have to give me another name, but I'll get that as a sub. So SMRs are small modular reactors on the nuclear side. But another name, you've given me. Oh, you give me 5.
Yeah.
Tyler Stevens, Toby Rice, Chris Wright, Jesse Pelton, Nick Gates.
Yeah.
Okay. Start with some of those.
Well, I'm very excited for you. Consistency is key.
Yeah. We're gonna be recording in the podcast studio.
Podcast production is a grind. Okay.
I'm gonna be on top of this. I got a strong team. It's one of the reasons why we're working with TFTC. We have beautiful studio here in Austin, Texas. Great team.
We've got a mute in
all
the
the infrastructure perspective. Great feed. Yeah, we're gonna rely on Logan's fact checking us from time to time.
He's gonna fact check. Thumbs up. Okay.
That video that Logan did when he was, what was the video you were selling? Some class. I was like, I didn't even know Logan can speak.
Can act. He can act. He can dance. Got some jokes.
Engaged the right way.
Yes.
Yeah. So.
Well, I'm happy for you.
Yeah.
What's your sign off? That's a big thing.
I'm not doing. I don't know. Got to think about that. I'm just gonna copy you with a final thought, or
we're gonna zoom out from the center of Hash. I don't know. We going with center?
That's all, folks.
Nah, that was Bugs Bunny, or is it the pig? Porky the pig.
I don't know. Think about it. We got to figure out the name first in the next few days before we release it.
Hash found. Next block. I don't know.
Yeah.
All right, we'll just end it.
Till next time.